Okay, so picture this. You need to teach a robot a brand new, pretty complex skill. For years, that whole process would take weeks, sometimes even months, of just painstaking, repetitive work. But today, we're going to look at a new breakthrough from NVIDIA called GR00T that totally flips the script, shrinking that timeline from weeks down to just a few hours. Let's dive in. So let's just start with that really fundamental question. It's one that used to be incredibly hard to answer, right? You have a robot arm sitting there. How do you actually teach it to do something new, like sorting objects or picking up a specific block? Well, it turns out the entire rulebook for how we do that has basically just been thrown out the window. And this, right here, this is the core of it all. We are moving from a world that required literally thousands of tedious, manual demonstrations to teach a single task down to needing just a few dozen. Look at those numbers. This isn't just a small step up, it's a completely different way of thinking about how we work with machines. Now, to really appreciate just how big a leap this is, we gotta rewind and understand the old bottleneck. I mean, why was teaching robots always so painfully slow? Well, for decades, the problem has been that every single robot started as a total blank slate. So in the past, teaching a robot meant showing it the exact same task over and over and over again. I want you to really think about that. Physically guiding a robot arm through the motions, potentially thousands of times just for one simple action. This wasn't just boring, it was incredibly expensive and a massive barrier to getting useful robots out into the real world. But what if the robot wasn't a blank slate? What if it already had some basic foundational understanding of the world? You know, how gravity works, how things move, the basics of how to grip an object, before you even started. Well, that is the game-changing idea behind NVIDIA's new model, GR00T. See, GR00T learns through a process called imitation learning. And it's pretty much exactly what it sounds like. The robot learns by watching a human do something. You show it the task just a few times, and the robot starts to figure out how to copy you. But the real magic here is how GR00T's existing knowledge makes that whole imitation process so incredibly fast and effective. This analogy is just perfect. The old way was like hiring a trainee with zero experience, and you have to teach them every single basic thing from the ground up. The new way, with GRT0, is like hiring a seasoned veteran. They already have this huge skill set. You just need to show them the specific workflow for this job, and they pick it up almost immediately. So you're probably asking, how does it get all this experience? Well, GR00T is what we call a foundation model, which is really just a fancy way of saying it's been pre-trained on a massive, super diverse library of information. It's watched countless videos of people doing things, it's analyzed data from other robots, and it's run through millions of scenarios in virtual simulations. So it basically arrives on day one already knowing a ton. Okay, so you have this incredibly knowledgeable general-purpose model. That's great, but how do you actually teach it your specific task? This next step is called fine-tuning, and it's where you take all that general knowledge and you adapt it for one specialized job. And, you know, the process itself is surprisingly simple. First, you just record about 40 quick demos of the task you want it to learn. Then, you feed that data into the GR00 model to fine-tune it. After that, you run a quick check to make sure it actually learned it right. And finally, you deploy that new skill to your real-world robot. And that's pretty much it. Now, this fine-tuning part isn't instantaneous. You can see it can take a few hours to run, but here's the key. This is a process you can just kick off at the end of the day and let a computer handle it overnight. When you compare that to weeks or even months of hands-on data collection the old way, the speed up is just incredible. Okay, the training is done, but how do you actually know if it worked? And maybe more importantly, how can you be sure the robot has learned the skill correctly before you let it loose on expensive real-world hardware? Well, that's where this crucial step of evaluation comes in. The method they use for this is called open-loop evaluation, and you can think of it like giving the robot a little pop quiz. You take your original demonstrations, those are the correct answers, and you show the robot the starting point of each one. Then you just ask it, okay, what would you do next? And you simply compare its answer to the original correct answer to see how well it learned the lesson. And here is what it looks like when that test fails. Big time. On this graph, that solid line, that's the correct action from the human demonstration. We call that the ground truth. The jaggedy pink line is what the new model predicted it should do. And as you can see, it's all over the place. This model is just nowhere near ready for prime time. And this This is what you want to see. This is success. After a bit more fine-tuning, you can see the model's prediction, that dotted line, is now tracking the ground truth almost perfectly. This simple visual check gives developers the confidence they need to know, yep, this skill has been learned correctly, and it's safe to deploy on a real robot. So let's just step back for a second and look at the big picture. What does all of this really mean? Well, by making robot training so much faster and cheaper and more accessible, this kind of technology just tears down the barriers that have kept robotics stuck in the hands of a few specialized labs for so long. And that, right there, is the ultimate takeaway. Foundation models like Groot are a true game changer. They are transforming robotics from a field that demanded these massive data sets and elite-level expertise into something that anyone can push forward with just a handful of demonstrations and a single night of computation. Which really leaves us with a fascinating question, doesn't it? Now that this kind of power is becoming accessible to more and more people, and we can teach robots complex skills almost as easily as we teach a person, what should we do with it? What are the first most important problems we should solve? I mean, what would you teach a robot to do first?